Let's have a look at this GCSE past paper question on trigonometry higher tier. Question 6. The depth d meters of the water at the end of a jetty in the afternoon can be modelled by this formula here, where t hours is the number of hours after midday, a and k are constants. Yesterday the low tide was at 3 p.m, the depth of water at low tide was 3.5 meters, find the value of a and k. So this isn't like your usual trigonometry questions, it's more like an application and modelling question. However, this is how we would start it. So firstly, we can see that t hours is a number of hours after midday, and we know that the low tide happened at 3 p.m. So we know the midday is at 12 p.m. So we can now instantly write that t is going to equal to 3, because it's going to be 1 p.m, 2 p.m, 3 p.m. And then secondly, we also know that the depth of the water at low tide was 3.5 meters, and we know d is our meters of depth, right? So now we can instantly fill in our modelling equation. So we know that d is going to be 3.5 meters, and that's going to equal to our 5.5 plus a, which we don't know yet, sine of 30, t, which we know is 3, minus k. Then we can just slightly rearrange this by putting the 5.5 to the left-hand side, which ultimately makes minus 2 is equal to a sine of 30, 3 minus k. Okay, next we should use our knowledge of sine graphs. We know that the low tide here essentially represents, on the sine graph, the minimum point, aka the lowest point. And we know for our sine graphs, maximum is at 1 and our minimum's at minus 1. And we know when it is a minimum point, it's actually at 270 degrees. Okay, so firstly, we basically look back at this modelling question and we look, right, we want this sine 30, t minus k, to equal to minus 1. Okay, so what we can do here is just isolate this part here to minus 1, because we want to make it equal to the lowest point, right? So minus 2 is equal to a multiplied by minus 1, so a is equal to 2. Okay, so that's our first part of the question done. Now we want to find k. To find k, we, like said before, we want to isolate this part. So we can just put the sine 30, 3 minus k, is equal to minus 1. We want to just isolate this part because it's this part that is actually changing the value of the depth, okay? Due to its sinusoidal feature, it's always moving up and down, changing the depth, just like having a high tide and a low tide. So if sine 30, bracket 3 minus k, is equal to minus 1, then we just do some algebra on it. We can do the inverse of sine of minus 1, which you know is at 270 degrees. So we'll do 30, 3 minus k is equal to 270, because we just did the inverse of sine. Now we can just do some rearranging. So 3 minus k is equal to 270 divided by 30, which is going to be our 9. Then k is ultimately minus 6. Now we found the two values. A is equal to 2, k is equal to minus 6. So this may not be your usual type of trigonometry question, but it is worth 4 marks